Hello students, welcome back to Future Foundation. In last lecture, we have started product of vectors and got some idea of dot product and projection of one vector over other. Students, now in today's class, we will continue with dot product and will discuss its properties. So let's start the class. Let us write its properties. Properties of dot product. So first one is dot product is commutative, that is E dot B is equal to B dot A. Second, dot product is associative, means A dot B plus C can be written as A dot product is associative over addition. That is, it can be written as A dot B plus C is equal to A dot B plus A dot C. Third, let E vector is equal to E1 I cap plus E2 J cap plus E3 K cap, or more conveniently it can be written as E1, E2, E3, right? Similarly, B vector is B1, B2, B3. So A dot B will be E1, B1 plus E2, B2 plus E3, B3. Okay. Why it is so? Why A dot B is equal to A1, B1 plus A2, B2 plus E3, B3? This thing will be understood after few minutes. Now, E dot B is root over E dot B is nothing but mod A mod B cos theta. So this is root over A1 square plus A2 square plus A3 square into root over B1 square plus B2 square plus B3 square into cos theta is equal to A1 B1 plus A2 B2 plus A3 B3, right? So cos theta will be E1 B1 plus E2 B2 plus E3 B3 on root over E1 square plus E2 square plus A3 square to root over B1 square plus B2 square plus B3 square, right? Or it can be written as in compact form as sigma E1 B1 by root over sigma E1 square root over sigma B1 square. Okay. Now property 4 is if A vector is perpendicular to B vector implies E1 B1 plus A2 B2 plus A3 B3 is equal to 0. If A vector is parallel to B vector implies A1 upon B1 is equal to A2 upon B2 is equal to A3 upon B3. Okay. Question is mod of E vector plus B vector whole square plus mod of A vector minus B vector whole square is equal to 2 times mod of E vector square plus mod of B vector square. Is it true? Means I have to give answer in true or false. So from LHS, if I expand mod of A plus B whole square, students, E dot A is nothing but mod of A square. Similarly, mod of A plus B whole square is E plus B dot A plus B. Okay, and plus b dot a plus b is mod of a square plus e dot b plus b dot a plus mod of b square, right? And a dot b and b dot a both are equal, so I can write 2 times a dot b, so it is nothing but mod of a square plus mod of b square plus 2 times e dot b. Okay, similarly e mod of a minus b the whole square is mod of a square plus mod of b square minus 2e dot b. Okay, and it is mod of e plus b whole square, right? So therefore LHS will become mod of a square plus mod of b square plus 2 e dot b plus mod of a square plus mod of b square minus 2 e dot b. 2 e dot b and minus 2 e dot b will cancel out, so this will become 2 times mod of a square plus mod of b square. So it is true, is equal to RHS. So it is true. So I will use this as a result in coming questions. So let us take a question based on this result. If mod of A vector is equal to 11 and mod of B vector is equal to 23 and mod of A minus B is equal to 30, find mod of A plus B. Okay, so from mod of A plus B whole square plus mod of A minus B whole square is equal to 2 times mod of A square plus mod of B square. I will get mod of A plus B directly. So this is nothing but root over 2 times 11 square plus 23 square minus 30 square, right? So 2 into 11 square 121 plus 23 square, that is 529 minus 900. This is 1300 minus 900. This is root over 400 and root over 400 is 20. So this is mod of A plus B. This is the final answer. Okay, come to next question. If A vector is equal to 2 minus 3 6 and B vector is equal to minus 2 5 minus 14, find projection of E vector on B vector upon over projection of B vector on A vector. See, I have to find projection only, not projection vector. So projection of A vector on B vector is B dot A upon mod of B whole square. B dot A upon mod of B whole square means vector, which vector will be repeated? That vector is repeated uh, that vector is repeated on which projection is taken out, right? So if I have to find uh, a vector, projection of a vector on b vector, then uh, b vector will be repeated, right? So b vector dot a vector upon mod of b vector is projection of a vector on b vector upon projection of b vector on a vector. Now in second case, a vector is repeated. So uh, in second case, a vector projection on a vector is carried out. So a vector is being repeated. So a vector will be repeated. So I will write a vector dot b vector upon mod of e vector का square, right? So this is same thing, a dot b and b dot a, and also this is scalar quantity, so I can cancel this and it will become a vector का mod of a vector square upon mod of b vector square. So mod of a vector is nothing but root over 4 plus 9 plus 36 whole square upon root over 4 plus 25 plus 196 whole square, right? So this is root of 49, that is 7 ka square upon this is 196 plus 4 200 225 root over 225 means 15 square means 49 upon 225. This is the final answer. Okay, let us discuss some more questions. Question is, if e vector comma b vector comma c vector are unit vectors where a vector cap b vector is equal to b vector cap c vector is equal to c vector cap e vector is equal to pi by 3. Find mod of e vector plus 2b vector minus 3c vector. Okay, see, if I am writing a vector cap b vector, it is nothing but it is representing angle between a vector and b vector, right? So I have discussed this thing earlier also. So a vector cap b vector is pi by 3, means angle between a vector and b vector is pi by 3. So angle between all three pairs is pi by 3, and I have to find mod of a plus 2b minus 3c. See, this thing also has been discussed, has been pointed out so many times before, that if you are given mod in question, then you have to take square of that mod, right? So from mod of a plus 2b minus 3c vector whole square is equal to, this is nothing but a plus b plus c whole square, and a b c are vectors, so I will expand it in the same manner as I expanded a plus b whole square. So it will be mod of a square plus 4 mod of b square plus 9 mod of c square plus 4 a dot b minus 12 b dot c minus 6 a dots. Okay, so ABC are unit vectors, so this is 1 plus 4 plus 9 plus 4 into 1 into 1 into cos pi by 3 minus 12 into 1 into 1 into cos pi by 3 minus 6 into 1 into 1 cos pi by 3. because angle between all three pairs is pi by 3. So this is 4 plus 14 plus cos pi by 3 is 1 by 2. So 2 minus 6 minus 3. Okay. So 14 plus 2 16, 16 minus 9 7. So this is 7. So mod of A plus 2B minus 3C is equal to root 7. Okay. Now we are in properties. So we have discussed four properties. Now come to property 5. I dot I is equal to E dot J is equal to K dot K is equal to 1. See, now you will understand uh, point 3 and point 4. I dot I is equal to 1. See, these are three mutually perpendicular axes, x-axis, y-axis, z-axis. So in x-axis direction it is I cap, in y-axis direction which is j cap, and it is k cap which is in z-axis direction. These all are three unit vectors and these are perpendicular to each other. So this is 90, this is 90, and this is 90. So I cap I means I into I dot I means 1 into 1 into cos 0 degree, means angle between I and I is 0. So this is 1. Same for j dot j and same for k dot k. So this is 1, right? Similarly, I dot j is equal to j dot k is equal to k dot I is 0. Same reason, because I dot j is 1 into 1 into cos 90. 1 into 1 cos 90, and cos 90 is 0. So I dot j is 0. J dot k is 0 and k dot I is also 0. Right? And also if E dot I, so A vector is E1 I cap plus E2 j cap plus E3 k cap dot I, means it will be written like this: E1 I dot I plus E2 j dot I plus E3 k dot I, and I dot I is 1, so E1 plus j dot I is 0 and k dot I is also 0. So this will be E1 only. So E dot I is E1. So I will use this thing as a result in questions, incoming questions. So for example, question is given like this: say E vector dot I cap times I plus E vector dot j cap times j plus E vector dot k times E vector dot k times k cap is equal to what? Right, so I have to give the answer for this one. So E dot I is E1. So E1 I cap plus, similarly E dot j is nothing but E2. So E2 j cap plus E3 k cap. So E1 I cap plus E2 j cap plus E3 k cap is E vector itself. Okay. Now, so by seeing above, I can write R vector dot E vector times E vector plus R vector dot P vector times P vector plus R vector dot C vector times C vector is equal to R vector. Proof we'll see in coming lectures, but for the time being, convince yourself by this result. Question is E dot I square plus A dot J square plus A dot K square is equal to what? So A dot I is nothing but A1, so A1 square, plus A dot J is A2, so A2 square, plus A dot K is A3, so A3 square. So A1 square plus A2 square plus A3 square is nothing but mod of A vector square. Now students, come to next question. Question is, if R vector is equal to A square minus 4I cap plus 2J cap minus A square minus 9K cap is making acute angle with coordinate axis, then E belongs to question mark, right? Now beta, in question R vector is making acute angle with all three coordinate axes. It means I can write R vector dot I cap is greater than 0 and R vector dot J cap is greater than 0 and R vector dot K cap is greater than 0. So R dot I means A square minus 4 is greater than 0. 2 is greater than 0. It is greater than 0 uh, for all real numbers. And R dot K greater than 0 means minus of A square minus 9 greater than 0. So A square minus 4 greater than 0 implies A plus 2 into A minus 2 greater than 0. And it is always true. And A square minus 9 less than 0 means A plus 3 into A minus 3 is less than 0. So A belongs to minus infinity to minus 2 union 2 to infinity. It is for all real numbers, and here A belongs to minus 3 to 3. Now for A, I have to take intersection for all these three. So using number line, say minus 3 is here, minus 2 is here, 2 is here, 3 is here. So minus infinity to minus 2 and 2 to infinity. And this is for minus 3 to 3. So for intersection, I'm seeing interval of for A is this, that is A belongs to minus 3 to minus 2 union 2 to 3. Now students, let us take one more question. Let x y belongs to R such that 2 sin x sin y plus 3 cos y plus 6 cos x sin y is equal to 7. Find tan square x plus 2 tan square y. Students, see this question. We have to find tan square x plus 2 tan square y. It means we have to find tan x and tan y. That is, we have to find x and y. Well, if we have x and y, then we can have tan x and tan y. So there is a question of two variable, but we are given only one equation. Okay, 2 sin x sin y plus 3 cos y plus 6 cos x sin y is equal to 7. Now in this question you will see the beauty of vectors. Through vectors we can give the answer. So you have also seen before vectors we cannot solve uniquely uh, one equation with two variables. We cannot give answer in a unique way, but using vectors we can give. So see, so I will use vectors. for this particular question. So let A vector is equal to 2i cap plus 3j cap plus 6k cap, and B vector is equal to sin x sin y I cap plus cos y j cap plus cos x sin y k cap, right? Now from A dot B is equal to mod A mod B cos theta, what I can write? A dot B means if A is this and B is this, so A dot B will become 2 sin x sin y plus 3 cos y plus 6 cos x sin y is equal to, in right hand side it is root over 2 square plus 3 square plus 6 square into root over sin square x sin square y plus cos square y plus cos square x sin square y into cos theta, right? So 2 sin x sin y plus 3 cos x cos y plus 6 cos x sin y, it is given in the question as 7, so I will use 7 here, is equal to root over 2 square plus 3 square plus 6 square root over 49, that is 7 root over sin square x and either sin square x sin square y, so sin square y, and in last term cos square x sin square y sin square y. I will take sin square y as common, and in bracket there will be sin square x plus cos square x, which is 1. So here sin square will remain, sin square y will remain plus cos square y, and it is again 1. So 7 cancel out, it is 1. So cos theta will become 1. So theta will be 0 degree. It means A vector is parallel to B vector. So if A vector is parallel to B vector, implies A1 upon B1 is equal to A2 upon B2 is equal to A3 upon B3. And in question I can write A1 B1, A2 B2 and A3 B3. So A1 is 2. So 2 upon sin x sin y. A2 is 3. So 3 upon B2 is cos y is equal to A3 is 6. So 6 upon B3, which is cos x sin y, right? Let us take it as k. So sin x sin y will become 2 by k, cos y will be 3 by k, and cos x sin y, which is 6 by k. So it is sin x sin y is equal to 2 by k, means now if I use these two, so answer will be, if I use these two sin, if I divide this by this or first by third, so sin y cancel out, so this is 10x. 10x is equal to 2 by 6, that is 1 by 3. And if I use this and this, or first and second, then sin x into 10y will be 2 by 3, right? So if 10x is 1 by 3, using triangle perpendicular upon base, so hypotenuse is root 10. So 10x is 1 by 3, so sin x is 1 by root 10. So I will put sin x in this, so it will give me 10y is equal to 2 by 3 into what? 1 upon sin x, and sin x is 1 by root 10, so this is root 10. So now what I have to give the answer in what I have to give in answer I have to tell 10 square x plus 2 10 square y. So 10 square x is 1 by 3 whole square plus 2 into 10 square y is 2 by 3 into root 10 whole square. So 1 by 9 plus 2 to the 4 to the 8 10s are 80 by 9. So 81 by 9. So answer is 9. So this is all about this question. So now students, let us stop this class here. मिलते हैं नेक्स्ट क्लास में. तब तक बाय बाय, टेक केयर. थैंक यू बच्चों.